Alright, hello and welcome. In this module, we are going to be learning different type of data warehouse design approaches. To build a successful data warehouse and to save time and cost, selection of the right data warehouse design is the key technique. There are two different design approaches, top-down and bottom-up, which are normally followed when designing a data warehouse solution, and based on the requirements of your project, you can choose which one suits your particular scenario. Both philosophies have their own advantages and differentiating factors, and enterprises continue to use either of these. These methodologies are a result of research Bill Inman, which proposed the top-down approach, and Ralph Kimball that offers the bottom-up approach. So let's have a look now. So you see that for both approaches, we are starting with extraction data from different variety of source systems and transform it within the staging area. For the next steps, Inman defines a data warehouse as a centralized repository for the entire system. The information is gathered and integrated first in a normalized data model. N-dimensional data marts which contain data required for specific business processes are created only after the complete data warehouse has been created. In Ralph Kimball's dimensional design approach, the data marts are created first to provide reporting and analytical capabilities for specific business processes as quickly as possible. Afterwards, these data marts can then be integrated with confirmed dimensions in order to create a comprehensive data warehouse. Kimball uses the dimensional models such as star schema or snowflakes to organize the data in both data marts and enterprise data warehouses. But against this, Inman uses the ER modeling, which is normalized the third normal form for enterprise data warehouse, and dimensional model for only data marts. So before detailing further, I just want to give a little overview about some basic concepts we frequently use in here, because sometimes all these terms top-down, bottom-up, ER modeling, normalized databases are used interchangeable, and that causes a little bit confusion even if they don't have the exact meaning in behind. Okay, let's jump back to our previous slide. As we mentioned earlier, top-down and bottom-up are data warehouse design approaches that tells us if do we need an enterprise data warehouses that work as a single point of truth, or main objective for us to get quick delivery with a high level of performance, so that data marts will be the main objective. So that is totally depends on the cost, budget, timeline and the requirements of your organization. And the next critical step when defining data warehouse approach is we need to determine how we are going to organize data in enterprise data warehouses or data marts. There are two data modeling techniques in here, ER and dimensional model. We are going to detail dimensional model in following sessions, but for ER model to shortly remember, it is developed to design relational databases by turning entities to tables, attributes to columns, or relations to foreign keys in a physical database. But ER model is not always in a suitable or preferred structure for relational databases. So we need to optimize the model in order to get rid of data redundancy, hence the anomalies in the systems. That is why we normalize ER model with the help of normal forms and finally end up with the third normal form. So this is why when we talk about enterprise data warehouse or entity relational model of Inman, we mainly mean the third normal form structure. So I just want to make it simple because it causes a little bit confusion. That is why I just gathered all them in a table. So when we're considering data warehouse design, you may see that all these terms, Inman, bottom-up, ER model, normalized databases, or 3NF form would be used interchangeable, even if they don't have the exact meaning in behind. So please make yourself familiar about these terms. On the other hand, bottom-up, Kimball method, dimensional model, denormalized database or star schema is also frequently used instead of each other. So additionally, I would like to take attention also in here, in OLTP systems, we also use ER model and mostly they're also normalized to 3NF structure. But keep in mind in here, there are functional differences between ER model used in Inman enterprise data warehouses and OLTP databases. Okay, now let's jump back to our design approaches again and do some detailed comparison to get a better understanding. When we consider the characteristics of the top-down approaches, we already mentioned that there are two data storage layers in top-down approach. The first layer is an enterprise data warehouse, and on top of it, the subject-specific data marts are built. So data warehouse has atomic level data, and data marts have summary and aggregated data. And data warehouse use a normalized model which lower the data redundancy and provides the fast insert. On the other hand, data mart use a subject-specific dimensional model. And when we look at the Kimball's bottom-up approach, the main characteristics in here, the bottom-up approach emphasizes the data marts and starts by designing a denormalized dimensional model for data mart. Data marts contain both atomic and summary data, and they can provide both enterprise and function-specific views. And data marts also deployed incrementally and integrated using conform dimensions. But what are the advantages and disadvantages of both approaches? The key advantages of the Inman approach are the data warehouse truly serves as the single source of truth for the enterprise. As it is only source for the data marts, they will have consistency when they overlap. And it is also very flexible. As the business requirements change or source data changes, it is easy to update the data warehouses as one thing is only in one place in normalized data model. Initial cost is high, but subsequent project development cost is lower. And the disadvantages of Inman method are it represents a very large project, so the initial setup and delivery will take more time and management need to be aware of this, and sometimes they are not very happy about that. And for a while later, the model and implementation can become complex over time as it involves more tables and joins. On the other hand, this technique is inflexible to changing departmental needs. As we already mentioned, top-down approach is focused on more enterprise data warehouse requirements, and to get quick delivery for specific business processes, it is not suitable for this requirement. And when we look at the advantages of the Kimball method, the major benefit of the bottom-up approach is that it focuses on creating user-friendly, flexible data structures using dimensional star schema models. It also delivers value rapidly because it doesn't lay down a heavy infrastructure upfront, and it is quick to set up and build, and the first phase of the data warehousing project will be delivered quickly. Dimensional model can easily understood by business users, and it is easy to use for reporting. And most BI tools work very well with star schema, and also the performance of the star schema model is very good. So it works very well for department-wise metrics and KPI tracking. It is easier to extend the data warehouse. It can easily accommodate new business units. It is just creating new data marts and then integrating with the other data marts with the conform dimensions. And the main disadvantages of the bottom-up design is the essence of the one source of truth is lost. So data is not fully integrated before serving reporting needs. Cannot handle all enterprise reporting needs because the model is oriented towards the business processes. The initial cost is low, but each subsequent phase will cost the same. And it is also difficult to maintain, and because the data is often redundant due to denormalized data model, and whenever you want to do any change in the system, you need to update this change in multiple areas. So these are the two different traditional data warehousing solutions, which each of them have their own strengths and disadvantages. Depends on your business requirement or project delivery timeline or strategy, one of them, sometimes the mixture of them would be useful. But recently, dimensional model, which is created by Kimball, started to come forward. So you may observe when it comes to data warehousing, it is mostly referred to dimensional data model. That is why we are going to focus on dimensional modeling in the further sessions. Thank you for listening.